Hey, we're going to do whiteboard problem 10.6. So we have a 60 kilogram student jumps from a 10-meter platform at a swimming complex into the pool below. So first we want to find her potential energy at the top of the platform, then kinetic energy just as she reaches the water, and the velocity. Okay, so let's do those first. Okay, so I wrote some of that stuff down while we were reading it, right? So we have mass of 60, we have initial height of 10. We want to find for part A what the initial potential energy is. And then, I just want to see if I can follow focus works. Okay, I'm not sure if that's any better. Okay, so let's get our picture here. So here is the diver. Going off the top of the 10-meter platform. And then she's going to be hitting the water below, right? This is our 0. So we want to know what is V final here as well. Okay, so we want to know what our potential energy is here, and then the final. So let's just do our energy bar charts so we can visualize what's happening. Energy bar charts. Okay, so initially we have gravitational, and our kinetic energy will be 0, and then at the end, our gravitational potential energy will be 0, and we will have everything stored in kinetic. So I'm going to say my y equals 0 here. Okay. All right, so that would look like all of our energy stored is gravitational, nothing in kinetic. At the bottom, we have nothing in gravitational, and we'll have everything in kinetic. Okay, so this problem is forcing us not to do algebra first. I know you guys are disappointed, but so part A, what is our initial gravitational energy is going to be mgh. So our mass is 60 kilograms, gravity is 9.8 meters per second squared, and our height is 10 meters. So if we round that up, we could say it's about 6,000. Well, that's probably good enough. 6,000 kilogram meter per second squared, that's a Newton, times a meter is a joule. I'll put that a little approximate because I rounded 9.8 to 10. Okay, and then B, what is our kinetic energy final? Well, our conservation of energy equation here says that UG initial plus K initial equals UG final plus K final. Right? So this is 0, this one's 0. So our kinetic energy final is exactly what we started with in gravitational potential energy. So that's easy. So that's equal to UGI, which again is about 6,000 joules. Feel free to calculate that out if you'd like a more precise number. Okay, and then we want to find our velocity, right? So we have K final is 1/2 m v final squared. So we have, we want to find this. So v final is 2 k final divided by the mass, and then we take the square root. So 2, it's killing me to be doing this out without doing our algebra first, but what are you going to do? Okay, 2 times our energy, and then we divide by the mass of 60 kilograms. That takes care of 1 0. This takes care of our 6. So we have 100, 200, square root of 200, which I don't know off the top of my head. So square root, we'll just do it out here, right, of 2 times 6,000 divided by 60. And final. Ooh, that's pretty fast. 14.1 meters per second if we're just keeping 3 significant figures. Okay. What else did this ask? There's a lot of parts on this one. If the mass of the diver is increased, would K final increase, decrease, or remain the same? Okay, so our mass would go up here, right? In the initial potential energy. Oops, not that you can see my camera. So if we, so part C, if we increase mass, what happens to K final? Okay, so if we increase our mass, our initial potential energy is going to go up. Our K final is just equal to that, so our final kinetic energy will go up. And then D, or part 4, if the mass of the diver is increased, would the final velocity increase, decrease, or remain the same? Okay, so D is the same thing. And then what happens to V final? So here it's useful to do our, write out the equations, right? So we have mgy initial equals 1/2 m V final squared. And the mass actually cancels out, right? So if we solve for V final, there is no dependence on mass. So V final does not change if we change the mass. Okay, and there was one more. How does your answer change if your height is doubled? Okay, so let's go ahead and just solve for V final here. Squeezing it in down here. So I get V final equals the square root of 2gy initial. Okay, so if y initial goes to 2 y initial, then my V final is going to go to the square root of 2 times the V final that I got, right? Because I'm adding a factor of 2 inside the square root, I get a square root of 2 outside. And that is that.